everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about filter circuits. In our last classes, we already completed the discussion on rectifiers. So, rectifier circuit output is nothing but pulsating DC. In pulsating DC, AC as well as DC both components are present. So, to remove those AC components from the output, we need filter circuits. So, after that, we will convert that pulsating DC into steady DC. Now, as a part of definition, a filter circuit is a device that is used to remove the AC component of the rectified output but allow the DC component to reach the load. A filter circuit is in general a combination of inductor and capacitor called LC filter circuit. A capacitor allow AC only and inductor allow DC only to pass. So, a suitable LC network can effectively filter out the AC component from the rectified wave. Now, we will discuss all filters one by one. So, this is the circuit structure of capacitive filter. Now, here we can see that a capacitor is connected in parallel to the load resistor RL. Before we go through the circuit, we will discuss the capacitive reactance, which is XC. XC is nothing but 1 upon omega C. So, omega is nothing but angular frequency, which is 2 pi f. So, Xc is our 2 pi fc. Now, here f is a frequency term. So, for DC, the frequency or f is equal to 0. For DC component, frequency term is 0. So, what will happen? Xc will 1 upon 0 in case of DC signals. And Xc is nothing but infinite. If we consider 1 upon 0, we will get it infinite. So, 1 upon 0 is infinity. In this case, what is happening? The reactance of capacitive filters are infinite. It means they are providing infinite resistance for DC components. Similarly, it means that it works as open circuit when DC component pass through it. So, capacitor are DC blockers. They block DC and just allow pass AC inside them. Now, we will discuss the circuitry here. What is happening in the circuit? Now, here what is happening? I am making the waveform here. So, it is increasing from 0 to 1, 2, 3 and going till Vmax. We are considering this. So, output waveform maximum at Vmax and capacitor voltage we are considering Vc. So, when the capacitor voltage is smaller than Vmax, it means when this capacitor voltage, this voltage is smaller than Vmax, then the capacitor is charging. In this region, capacitor is charging. When the input is increasing from 0 to Vmax, the capacitor is charging. What happens when this input is going down from Vmax to 0? So, when this Vc is greater than Vm. Why so? Because now Vm is going towards 0. So, Vm will be become negative and going to the lower edges. So, Vm value will be decreased. So, when Vc is greater than Vm, then this capacitor will discharge. Okay. So, capacitor have two properties, charging and discharging. When the peak is going above till Vmax, the capacitor is charging. When the capacitor voltage is greater than the Vmax, okay. When Vmax is lowering down its peak, then this capacitor is discharging. So, due to the process of charging and discharging, the peak is maintained. Okay. Let's suppose when capacitor is charging, this is the output. Let's say output is this. When capacitor is fully charged and now the input waveform is decreasing, at that time capacitors, whatever the value stored in capacitor is discharging. So, capacitor value is that and capacitor is discharging at that time. So, a voltage level is maintained at a particular level and not go beyond that level. So, what we are doing, we are just managing a level here. Again, this will happen. Current will increase and blocks towards a particular range like that. So, what is happening here? A particular level is maintained. Voltage or current, whatever it is not going to the 0 point. It means the, a steady level is coming shortly here. So, a steady level is coming. So, this is nothing but a steady output, steady DC. We can consider that a steady DC. So, it is depend on the charging and the discharging of the capacitor. Now, what is happening? We are connecting this capacitor in parallel form. So, what is the need of connecting is in parallel form? When AC component is coming, it will pass with the capacitor, and if AC component is passing at that time, this capacitor behave like a shunt or short circuit. So all the AC component whatever coming are grounded, and at output when this or short circuited output, what we will get only the DC component. And when DC component is coming toward the capacitive filter, already it is work as open circuit. So whatever the input voltage is, that it is going towards the RL. So DC level is maintained. AC, whatever the AC component are there, it is flowing towards the capacitor, and capacitor making those components to ground, and the DC component, it is followed by the resistor RL. So this is the whole working of what a capacitor filter is doing. Here one thing we have to notice, that Xc for DC component is infinite. So it is doing as a blocker for the DC components and pass for the AC components. So this capacitive filter is also considered as shunt filter. Okay, shunt capacitor filter. It is also considered as shunt capacitor filter. Why so? Because this is connected in parallel, and in this manner it is just shunting or short circuiting the AC components here, and we at output we are getting only the DC components. Now the second filter is our inductive filter. Okay, inductive filter are also considered as series filter. Okay, series. In this, the inductor is connecting in series with the load resistor RL. So these are also series filters. Now, inductor have one property, that inductor oppose any change in the current flowing through it. This is the property of inductor. When current tend to change, a back EMF is induced and prevent current from changing its value. What this definition means, that if this is an inductor coil, we know that in inductor the energy is stored in the form of magnetic field. So let's suppose this is the flowing current. Okay, now what happen if it is flowing towards the inductor, current is flowing towards the inductor, and what happen if current is very high, let's suppose this level. So it is stored in this inductor, and when current is very low, in this case the energy stored in magnetic field, whatever the energy stored in form of magnetic field, it will produce the back EMF, and it will make this thing up here. So the peak will never go down. Peak will never go down. Why so? Because a back EMF is working in this magnetic field. EMF is electromotive force, which is just managing to change the levels. Okay, now this level will shift towards this. So again, this level is here. Again, if negative come, it will shift towards this. So a particular level is maintained. Why so? Because this inductor has a property that when the current is changing in a particular manner, it produces a back EMF to counter that current and provide extra current to managing the level, and also taking the current from the input to managing the level. Okay, taking means the capacitor is storing the energy in magnetic form, and giving means it is giving that magnetic, it is producing the back EMF and giving the energy to the system. So that if this is the input waveform, this is the input waveform. So at output what we are getting, at output we are getting this kind of output waveform. Okay, where the variations are little, variations are very little, minimal variations are there. So this pulsating DC is converted into the steady DC now. Okay, so this is the working of what a L filter is doing. Now second thing, what it is connected in series, it means what is happening. If we consider the reactance of capacitor inductor, then what is XL? XL is nothing but omega L 2 pi Fl. So now what has happened? Frequency is directly proportional to XL. In DC component, frequency is 0. So XL is 0. XL, it means impedance or resistance is 0 in case of DC. It means all DC component will pass through it, and F will be, let's suppose, some value X here, or in maximum case we can consider it as infinity. Let's suppose 50 hertz we can consider, or in maximum case it will be infinite. Maximum case means the range beyond everything is infinite. So if we consider the maximum range of frequency, then XL will become infinite for AC signals. It means it will providing the infinite resistance for AC signal. It means it will behave as an open circuit for AC component. So what is happening for AC signal, inductor is behaving as a blocking bias, and for DC component it is similarly working as a flowing path or providing the path to the DC component. That's why it is connected in series. In earlier we see that capacitor connected in parallel, and here we see that inductor connected in series. It's connected in series, it is providing a path for DC and output we will get DC. So in inductive circuit, current is the output value. Okay, current is flowing towards the load resistor and it is the output value. And in case of this one, in case of capacitive, what happened, the voltage we are receiving at the output is the voltage we are receiving at these nodes are the output of the RL. So node which are here and here, because what is happening, it is providing the shunt path for AC components, so AC components are gone, and when DC components come it will behave as an open circuit. So what voltage is transferring to the RL, in this voltage is transferring, so RL is a factor of voltage here. Similarly in L or L filter or inductive filter, current is a factor of output here. So in this class, we clearly consider two filters. One is capacitive filter, another one is inductive filter. So for now, this is much for today. We will discuss LC filter and pi filter in our next class, and comparison of filters we will also do. So for today, this is much. Thanks for watching, and don't forget to subscribe and share this for needy ones. Thank you.